Let's start this video with a quick game. See these three circles here? I'm going to label them 1, 2, and 3. In a bit, I'm going to remove the numbers and move the circles around. Try to keep track of what each circle's number is. Good job if you got all three. The point of this intro is to get warmed up with thinking about circles. In this video, we're going to be tackling two questions. If you're given the position and size of a circle, how do you determine the equation? Then, flipping the question around, if you're given the equation of a circle, how do you determine its position or size? Alright, let's start by tackling the first question. I'm going to draw a circle and then write out the equation for the circle. And just bear with me for a bit. I'll show you why I'm writing it this way later on. As I move this circle along this graph, see what happens to the equation. What changes when I move the circle right or left? Do you notice any pattern? The pattern is whatever x coordinate the center lies on, that number will be subtracted from x in the function. Now let's try the same thing for y. Let's see if the same pattern appears. So, when I set my y value to 3, 3 is being subtracted from y in the equation. When I set my y value to -3, -3 is being subtracted from y in the equation. So whatever y coordinate my center lies on, that number is being subtracted from y in the equation. Okay, so we know that the center matters when trying to figure out the equation of a circle. Whatever x value the center is, we square the difference x has with that x value. And whatever y value the center has, we square the difference y has with that y value and add it to our x. But why is there a 1 on the other side of the equation? To answer this question, let's see what happens when we make our circle bigger. So we can see that the last number is related to the radius of the circle. And for those of you who saw the pattern, good job, because this last number will always be the square of the radius of the circle. So when our radius is 3, the last number is 9. And when our radius is 1, well, the last number is just 1. Okay, I'm going to plot a circle now, and I want you to pause and try to write out the equation of this circle. And then maybe comment because that triggers some YouTube algorithm thing. Alright, let's do this together now. Let's start by writing out the center and the radius of the circle. Now, the x coordinate of the center is 4, so let's take that 4 and subtract it from x and square that whole entire thing. Now, the y coordinate is 2, so let's take that 2, subtract it from y, and then square that. And then the radius is 2, so 2 squared is 4, and let's put that 4 on the other side of the equation. And there's our equation. Now good job if you got this. Let's have another go at this, but with a different circle. Now this time, I'm going to put this circle in the third quadrant. See if you can find the equation of the circle. Alright, this time it's still the same approach. Let's first write out our x and y coordinates of the center, and then write out our radius. Okay, this time let's write out the equation using variables, and then plug in the variables. So in this case, h is the x coordinate of the center, k is the y coordinate of the center, and r is just the radius of the circle. Let's start plugging things in. Our x coordinate is -10, and double negatives cancel out, so that's just +10. Our y coordinate is -3, and again, double negatives cancel out, so that's just +3. Our radius is 3, and 3 squared is 9. So now we have our equation. To recap, we first found the x coordinate of the center, we found the y coordinate of the center, and we found the radius, and then we plugged those three numbers into the three variables. And after a bit of simplification, we got our answer. Alright, let's try this the other way around now. Going from a circle's equation to its center and its radius. Give this a try. I'll give you 10 seconds. Yeah, no, just kidding. You can pause the video. Alright, let's do it together now. And I want to explain this in a way to show you why I'm doing it instead of just what I'm doing. So, we're doing what we did before, but in reverse. Remember, to get an equation from a graph, we first identified the center and radius, we plugged the numbers into the equation, and then we simplified to a form easier to read. So this time, when we're trying to calculate the circle's center and its radius from its equation, we need to do all three of these steps backwards. So, instead of taking our equation and putting it in a form easier to read, we need to take our equation and put it in the correct form. Then, instead of plugging the numbers into the equation, we need to pick out the numbers from the equation. And then, instead of identifying the center and radius from the graph, we identify the center and radius from the equation. So let's start by putting the equation into the correct form. Right now, our equation looks like this, but we want it to look like this. Let's first take our x plus 4 and turn it into an x minus negative 4. That way, it fits into the equation. And then, let's take our y squared and turn it into a y minus 0 squared. That way, it fits into what we want. Lastly, let's rewrite our 16 as 4 squared. And now we have our equation in the correct form. Let's move on to the next step. Pick out the numbers from the equation. Well, I've already color-coded this, so we don't really need to do this step. Let's move to step 3. So h is always going to be the x-coordinate of the center, and I've highlighted it in red. In this case, it's going to be negative 4. Now, k is always going to be the y-coordinate of the center, and in this case, I've highlighted it in green, so it's going to be 0. And lastly, r is the radius of the circle, and in this case, it's going to be 4. So basically, this last step is testing whether you know where the x-coordinate, the y-coordinate, and the radius lie in the equation. Alright, let's try something a little bit harder. So this time, the squares aren't already put in place for us. Let's look at this equation. So the important thing to notice about this equation is that there are loose x's and y's lying around, and if you look at our final equation, everything is nicely incorporated in one square. So we have to somehow get rid of that. Let's focus on the x squared plus 4x first, and try to put that in a square. So see how the term next to x is a 4? The only way we can incorporate 4x in a square is if we halve that and add it to x. So x plus 2 squared is x squared plus 4x plus 4. Now we only have an x squared plus 4x to work with, so let's rewrite x squared plus 4x as x squared plus 4x plus 4 minus 4. Now, to incorporate everything into a square, let's rewrite x squared plus 4 as x plus 2 squared minus 4. So to recap, what we just did was find the square that incorporates 4x, and then algebraically manipulate x squared plus 4x to look like that. Now, we're not exactly at what we want, but don't worry about this minus 4 for now, because it's going to go away later. Now, let's focus on incorporating all the y's in one perfect square. So, let's rewrite everything. In this case, we have a 2y lying around. Half of 2 is 1, so the only thing that incorporates y squared plus 2y is y plus 1 squared. Now let's write out y plus 1 squared, because that's going to equal y squared plus 2y plus 1, which is 1 over what we have. So now we know to rewrite y squared plus 2y as y squared plus 2y plus 1 minus 1. Now let's rewrite it as y plus 1 squared minus 1, because that's closer to what we want in the end. So now that we've found the squares that incorporate all our y's and x's, let's rewrite everything again. So instead of having x squared plus 4x plus y squared plus 2y, we now have x plus 2 squared minus 4 plus y plus 1 squared minus 1. Now, let's put all of our constants on the right side of the equation. Well, negative 4 minus 1 is negative 5, so let's add 5 to both sides. That leaves us with a 4 on the right side, which we can write as 2 squared. Now, we're in familiar territory. The number being subtracted from x is going to equal the x value of the center of our circle. And the number being subtracted from y is going to equal the y value of the center of our circle. And lastly, the number on the right side of the equation being squared is going to equal our radius. So now, after all that hard work, we can finally write out our answer. The center is at -2, 1, and our radius is 2.